When reading this question, the first thing we see that it says solve. It doesn't say prove. So we want to solve this equation. And when looking at this equation, at first it's like, whoa. There's like cos and then another cos and then sine and then another sine. And so far our experience with solving is that when we have cos and we have sine, we can't solve it because we have two different trig functions. Sometimes we could say, well, maybe we could factor one out. Factoring has been a strategy, but if I look at the first term and the second term, there's nothing in common to factor out. And we've also had some questions where we had like a cos squared theta you could change to 1 minus sine squared theta, but we don't have any squareds here, so we can't use that idea. So this is the main reason where, with all of our identities that we've learned up till now, you need to have them mostly memorized. By mostly memorized, when you see the first part of this equation, cos 4x cos x plus sine 4x sine x, that should immediately trigger in you, that's one of my formulas. Do I have a formula, and I can put alpha over this and beta over this and alpha over this and beta over this? Do I have a formula that matches that perfectly? Do I have a cos alpha cos beta plus sine alpha sine beta formula? Yes. That matches up with cos alpha minus beta. So that means I can take this first part and go cos 4x minus x, because that's my alpha minus beta, is equal to 1. And inside the brackets there, that could simplify. This just becomes cos 3x equals 1. So to start off with, we had to recognize our sum and difference formula to simplify this. And the nice thing is now we've got a single trig function. What kind of question is this now? We gave a special name to this question. Do you remember the name of it? This is a multi-revolution question. And again, the reason I give names to these questions is because we have a lot of stuff to learn. And if you can name something, that will help trigger in your memory, okay, how did we solve it triggers your memory to say, I've experienced that before. How did I do that in the past? How did I solve these multi-revolution questions? So you might remember, because you've given it a name, you might remember the first thing we did was we looked at our domain and said if our domain is between 0 and 2 pi for x, then if we multiply everything by 3, then 3x will be between 0 and 6 pi, which is 3 times around your unit circle. Hence the name multi-revolution question. And so we ask ourselves, is 1 on our pi plate? Yes. So the angle, which is 3x, when is cos equal to 1? Well, it's at 0 and 2 pi. That's the first time around. The second time around, it'll be coterminal and also at 4 pi. The third time around, it would include 6 pi. Here, I'm going to check my domain again. Notice there was no equal sign with the 6 pi. So that one went too far. So we only have 0, 2 pi, and 4 pi. And that's equal to 3x. Now, dividing each of those answers by 3 or multiplying by 1/3 gives us 3 answers all between 0 and 2 pi, which was our original domain. (15) and 17 for practice. So we start to see this as you get further along in math. You start to see this kind of idea that this question did not look like a multi-revolution question to start, but you recognize what you have currently, manipulate your equation, and then we got a multi-revolution question. And so that's a skill that keeps coming up, that different things that you've learned in the past appear again in the middle of other questions.